So this is 6.2b, still working on trigonometric equations, part 1. So let's look at example number 3. We have tangent squared x plus tangent x minus 2 equals 0, and they're giving me my interval. And this time they give my interval in radians, but it's still 0 to 360 degrees. And this is where we use some substitution here. Let's use x here. So x squared plus x minus 2 equals 0. So all I did, instead of writing tangent of x, I just made this whole thing, an x. Set that equal to x, and then that's squared, and then it's just an x. And then I can solve this using simple algebraic factoring. So I've got x minus 1, x plus 2. And now I'm going to put my tangent back in there for x. So tangent of x minus 1. So I'm just substituting it back in. It just makes it easier to do the math when I just have an x instead of a tangent. Alright, so now I have to set each one of those equal to 0. So the tangent of x equals 1. And negative 2. Okay, let's push this up there because all I really care about is this part right there. Alright, so I'm looking for a couple angles here. So tangent of x equals 1, that means my opposite over adjacent is going to be 1. So, and a positive 1, so that means it works there. And it also works there. So this is a 45-degree angle. And this one is 180 plus 45, so that one's going to be a, 225-degree angle, which actually means that this is going to be a pi over 4, and this will be, let's see, 145, 2 45s, 3 45s, 4 45s, 5 45-degree angles, 5 pi over 4 angles. So there are my two answers there. Alright, let's jump to example number 4. Example number 4. Find the solutions. Find all solutions if the cotangent of x, I'm not going to find all of them, I'm just going to kind of lead you through this type. Okay. So, let's go ahead and do distributive. Cotangent squared of x plus 3 cotangent x equals 1. And we'll set it equal to 0, so we'll subtract 1 equals 0. And notice what I have, a squared, an x, and no variable. So I really have an x squared plus 3x minus 1 equals 0, don't I? If I were to substitute cotangent squared of x with x squared and cotangent of x with x. So I'm just making cotangent of x, x, and then I square it. Can't factor that. So actually what we've got is, x equals negative b plus or minus square root of b squared minus 4ac all over 2a, quadratic formula. So when we plug in a equals, there's a 1 there, b is equal to 3, and c equals negative 1, and I plug into there, I get my x. And what did I say my x was? Cotangent of x. So my cotangent of x will be the answer when I do this quadratic formula. And I get as an answer negative 3 plus or minus the square root of 13 over 2. And that's pretty much as far as I'm going to have you go with that, is just realize that the angle that goes here for the cotangent is going to be an angle that gives me negative 3 plus or minus the square root of 13 over 2. In fact, why don't we keep going just a little bit more now that I look at this. Let's make a little more room here. I'm not going to do much here, but there's my answer. And I'm trying to find out what that angle is. I didn't find out the angle yet. If I do the math and I get a decimal, I'll find out that the cotangent of x is similar to negative 3.3 and positive 3.03. So when I do my math, I will get those two angles. So if I, because my calculator won't do cotangent, my cotangent of x is going to equal 1 over the tangent of x. So I can just plug these in here and get my two answers for what my x value is actually equal to, and I will get an x value of some crazy decimal. But that's it for that one. So let's look at example 5 and then we'll be done. Okay, example 5 gives us the tan of x plus the square root of 3, and they're saying that equals the secant of x, and they give us again the interval of 0 to 360 degrees, or 2 pi. One of the things that is important to get, when they give this interval to you, and if they give it to you as 2 pi, that means they're going to want the answer in radians. If they give it to you in degrees, like I just had 360, then they're going to want it in degrees. So they gave it to us as 2 pi. So let's see what we're going to do here. We do know that tangent and secant are related to each other by clear back in one of your other lessons is tangent squared x equals secant squared x. Okay, and they're related to each other by squares. So what I'm going to do here, or what the book does here, is they take tangent of x plus the square root of 3, and they square both sides. And when they square both sides, they get tangent squared x. I'm just using FOIL. Okay, so I didn't do anything weird there, I just did the FOIL. And then I know that secant squared x, and I just had it on there and I erased it. I've got everything in tangent form. So then I can look here and say, oh, I'm adding a tangent there, I've got one there, I can get rid of those. Those can go away. So I've got, let's see, 2 square root of 3 tangent x. Let's get the 3 over on the other side, which that's just going to give me a negative 2. Then I can divide both sides by 2 square root of 3. This is why you learned all that algebra years ago. Okay, give myself some more room here. So, tangent of x, oh, and these will cancel here and here, and that'll be 1. So I've got negative 1 over square root of 3, or square root of 3 over 3 when we rationalize the denominator. So we have negative square root of 3 over 3. Alright, so let's see what that looks like here. Now remember, that was the tangent of x. So the tangent of x equals negative square root of 3 over 3, which is opposite over adjacent. So my opposite has to be negative. And my bottom, well, either the top or bottom have to be negative. So let's just see what our options are here. All students take calculus. So it can't be in quadrant 1, can't be in quadrant 3. So it's going to have to be in quadrants 2 or 4 in order to get a negative. So I've got opposite of a positive, so this will be square root of 3, and this will be negative 3. My other option is down here, where my opposite is negative, and my adjacent is positive. So those are my two options there. So this angle here, and this angle here. So what is this angle that I have right here? If I took opposite over adjacent, which is the square root of 3 divided by 3, and I took the arc tangent of that, I get a 30-degree angle there. And that also means that this is going to be a 30-degree angle. So this angle right here is going to be how many 30-degree angles to get there? 1, 2, 3, 4, 5. So 5 30-degree angles. How many is it going to take to get all the way around to here? Well, it's going to take 6 to get here. 7, 8, 9, 10, 11. So it's going to take 11 30-degree angles to get there. So those are my two angles there. And I do it so much different than the book does, but that's the easiest way that I find to do it. I'd like to at least point your attention to solving trigonometric equations, top of page 253, and make sure that you're following what they're doing there as far as solving these. Just tells you when to use a quadratic equation, when to use different things. So again, what you're trying to do is you're trying to find the angle. So if you look up here, we're trying to find x, and that is the angle. So that's why we did all this work and used my unit circle here to find out what my two angles were that make this a true statement. So that's it for our lesson 6.2.